Hey guys, this is Mr. Lowry. We are working on this Proving Angles Relationships worksheet. If you missed class on day 1, we did most of this front page. Actually, we did all this front page in class and some of the other pages as well. So I'm just getting you caught up. Also, if you were in class but you want to go over these proofs again, just to kind of study them and get the idea, you can do that here as well. Now, in the last video I posted, I talked about the linear pairs theorem and we did a proof for that. Now we're going to move on to the congruent supplements theorem, and we're also going to talk about this thing called a flow proof. Okay? Let's start with the congruent supplements theorem and what it says. The theorem says if two angles are supplementary to the same angle, then the two angles are congruent to each other. Okay? If two angles are supplementary to the same angle, then the two angles are congruent to each other. Now, in order to just kind of understand that, in number 4, I asked you to give examples of what that's saying. So I gave a couple examples in class. Actually, I gave one, and then everybody else came up with another one. So let me show you what I'm talking about. Supplements or supplementary means they add to 180. Okay, so supplements are two angles that add up to 180. They're basically just supplementary angles. So you could call this the congruent supplementary angles theorem, but this is easier. So we need basically 3 angles here, and 2 of the angles are going to be supplementary to a third angle. All right, so let's draw that out. I'm going to draw an angle that looks kind of like this. And I'm going to draw another one that looks kind of like this. Okay, now these don't have to be a linear pair. That's why I didn't make them next to each other. They're just supplementary. And let's call this guy angle A, and let's call this guy angle B. Okay? Let's say this angle is 120 degrees. Okay? Now, if A and B are going to be supplementary, that means they have to add up to 180. So that would mean that angle A would have to be 60 degrees, right? But let's say we wanted another angle that was also supplementary to angle B. Well, it would have to be another 60-degree angle. So I'm going to try to do my best to match the other one that I drew. I'm not sure if that's totally accurate, but we'll call it good. Okay, we'll call this angle C. Right? So angle C, if angle C is going to be supplementary to 120 degrees, it also has to add up to 180 with 120 degrees. So the only option is 60. There's only one number, one angle measurement that you can add to 120 to get 180. So let's see what this is saying. If two angles are supplementary to the same angle, then the two angles are congruent to each other. Right? If A and C are both supplementary to angle B, that means they have to be the same number because there's only one number that I can add to 120 to get 180. So the conclusion here would be that, in this case, angle A would have to be congruent to angle C because they're supplementary to the same angle. Okay, now you can come up with your own example over here. Same kind of idea. Draw 2 angles that are supplementary and draw then a third angle that's also supplementary to the second, and you'll notice that they have to be the same angle. Okay, so that's just a number example. Okay, now what we want to do here is we want to actually use deductive reasoning. So we can't use specific numbers. We have to just use generic measurements. Okay, now we're going to write a flow proof, but I haven't explained what a flow proof is yet. So I want to talk about that kind of separately after we've already written the proof, so that we can just kind of take one thing at a time. So let's start with a 2-column proof. I know this is going to seem like we're doing the same thing over, but let's start with a 2-column proof, and then we'll translate it to this thing called a flow proof. Okay? So I've just got a scratch piece of paper over here, and we're going to just do a regular 2-column proof just to get started so we know what the idea is. Okay, so here's my 2 columns. Something like that. We got statements, we got reasons. Okay, let's take a quick look at our theorem again. So remember the if part is the given, and the then part is what we're trying to prove. So given two angles are supplementary to the same angle, prove that they have to be congruent to each other. So we're going to make a picture that demonstrates that. We're going to have two angles that are supplementary to the same angle. But we can't give them specific measurements this time. We're going to have to give them generic measurements. Okay, so let's draw a couple angles. Okay, and these don't have to be drawn a specific way. I'm going to kind of draw them maybe similar to the way I drew the other ones, but that's okay. Doesn't really matter. Okay, so I'm going to call this guy angle 1. I'm going to call this guy angle 2. And I'm going to do one more down here that we'll call angle 3. Oops, yeah, we'll call this angle 3. All right, so what we're going to assume is this part. We're going to assume that two angles are supplementary to the same angle. So in this case, we'll say, let's assume that angle 1 is supplementary to 2 and angle 3 is supplementary to 2. Or 1 and 2 are supplementary and 2 and 3 are supplementary. Okay, so given angle 1 and angle 2 supplementary, I'm going to abbreviate here, angle 2 and angle 3 supplementary. Okay, what we're going to try to prove is that angle 1 is congruent to angle 3. But we can't use specific measurements again. We have to use kind of algebra and unknowns. Okay, so statement 1, again, is just our given. So angle 1 and angle 2 are supplementary. And we'll just say this in the same line. Angle 2 and angle 3 are supplementary. We can assume that that's the case because that's the if part of our theorem. We're assuming that we have two angles congruent to, or excuse me, supplementary to the same angle. All right, now how does that help us? What does supplementary even mean? Well, supplementary means they add to 180. So my next statement, building off of number 1, would be that the measure of angle 1 plus the measure of angle 2 equals 180, because that's the definition of supplementary. I can also do the same thing with the second line. Measure of angle 2 plus measure of angle 3 has to also equal 180. Now, if you wanted to, you could actually make these two separate statements, like 1, 2, 3, 4, right? You don't have to. Typically, if you're going to use the same justification 2 times in a row and the statements are basically identical, you can kind of like double them up. So this is the definition of supplementary angles. So I'm going to put sup, and then I'm going to use the angle symbol with a little s on it. Okay? All right. So we have these two equations, and they're both equal to 180. So what we can do is we can set this expression equal to this expression. If two things are both equal to 180, then they also have to be equal to each other. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. So I've set this one equal to this one because I know they're both equal to 180. And that is the substitution property of equality. Remember, when I replace something with what it's equal to, that's substitution. Okay, now I can do all that, and that's great. Let's talk about where we're headed. Remember, we're trying to get angle 1 congruent to angle 3, right? So here we have angle 1, and here we have angle 3, and we basically almost have them equal to each other, but we have this extra stuff inside. We have the angle 2 and angle 2. But since these are on both sides of the equation, I can just subtract the measure of angle 2 from both sides and get rid of them altogether. That's the subtraction property of equality. So if I subtract the measure of angle 2 from the left, all I have left is measure of angle 1. If I subtract the measure of angle 2 from the right-hand side, all I'll have left is measure of angle 3. Okay, so subtraction property of equality. Notice that subtraction and substitution sound kind of the same, so when you're abbreviating, make sure you make your abbreviation long enough that you can tell whether it's subtraction or substitution. All right, now, did we prove what we set out to prove? We set out to prove that angle 1 was congruent to angle 3, right? Now, we're pretty much there. We know that this is similar to congruence, but this is actually an equation, and so we're going to change that to a congruent statement. If the measure of angle 1 is equal to the measure of angle 3, then we know that angle 1 is congruent to angle 3, because that's the definition of congruent angles. The definition of congruent angles is that they have the same measure. Okay, so starting with the fact that angle 1 and angle 2 are supplementary, but also angle 2 and angle 3 are supplementary, we can prove through algebra, without any specific angle measurements, that angle 1 has to be congruent to angle 2 in every case. Okay, now that's a two-column proof, right? You might be thinking, well, that doesn't help me out because I'm supposed to write this thing called a flow proof. All right, well, a flow proof has the same rules as a two-column proof. It's statements and it's justifications, and every statement needs to be justified. It's just the way that you write it is a little bit different. Okay, in a two-column proof, you obviously organize them in two columns. In a flow proof, what you do is it's almost like a flow chart. So every statement is going to be in a box. So we're going to take all these statements and put them in boxes, and then we're going to draw arrows in between them to show the logical flow. So let's start with statement 1. Angle 1 and angle 2 are supplementary, and also angle 2 and angle 3 are supplementary. Now, since we're talking about two different equations here, we're going to make these into two different boxes. Let me show you what I mean by that. Okay, so my first statement here, I'm going to say that angle 1 and angle 2 are supplementary. And I'm going to put those in a box like this. Now, under that box, I'm going to write the justification, which was given. So instead of writing them on the left and the right, I do box and then justification underneath. Okay, now I also had two other angles. So what I'm going to do here is I'm going to make two more. Sorry, another one. Okay, and this one says angle 2 and angle 3 are supplementary. Okay, again, that was given. The reason why I'm splitting them up into two is because these I have two different, I don't know, you can lump them together if you want, but it'll make sense in the logical flow why we have two here in a second. Okay, so angle 1 and angle 2 are supplementary. What does that mean? It means that the measure of angle 1 plus the measure of angle 2 is equal to 180. So now we have an equation, okay, and that was remember the definition of supplementary angles. Okay. So now I'm doing these two statements. Okay, so I need this one. Measure of angle 2 plus the measure of angle 3 equals 180. So this statement, angle 2 and angle 3 are supplementary, logically flows into the fact that measure of angle 2 plus measure of angle 3 equals 180. And again, that's definition of the supplementary angles. Okay, now notice that in line 3, these two different scenarios, these two pairs of angles merge into one statement. So over here, it's almost like we have two independent pathways. We have, okay, 1 and 2 are supplementary. That means they add to 180. 2 and 3 are supplementary. That means they add to 180. But now all of a sudden we merge, and we can say that measure of angle 1 plus measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And that was the substitution prop of equality. Sorry, I cut that off. I apologize. Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. All right, so we've kind of merged our two chains of logic here. Okay, now we're going to go to the next thing. Now, if you the way that this is organized is actually not important. Like the way that the spatial arrangements here. If you want to go left to right, you can. You could also go like top to bottom, or you can zigzag around. It doesn't really matter because the arrows show where your reasoning is going. So if I start running out of room, sometimes I just go like down or off to the side or whatever. It doesn't really matter. So let's actually go up here because we have some more room going up. So these two chains of reasoning goes to this one. Okay, so what is it? Where do we go from here? Right? Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. So remember what we did from there is we subtracted the measure of angle 2 from both sides. Okay, so that turned into measure of angle 1 equals the measure of angle 2, or sorry, the measure of angle 3, excuse me. Okay, and that was the subtraction prop of equality. Okay, and then our last move, I'll just go this way, is that angle 1 is congruent to angle 3. And that was the definition of congruent angles. Okay, so it's like a flow chart, right? You just have these ideas kind of flowing into another idea. The kind of nice, the cool thing about a flow chart proof is that sometimes if you have like more than one equation or whatever that you're going to combine later, you can kind of like keep them separate for a while and say, okay, here's one idea that flows into this idea, and here's another relationship. So two different relationships that are flowing into the same equation. You can kind of show that, which is cool. Okay, so that's a flow proof, and that's the flow proof of the congruent supplements. I'm going to ask you to do a couple more flow proofs in this assignment, and so this will be a good example to reference later.